All right, everyone, we're going to do one more problem here before we finish up this math review. I think this is a real important concept to get squared away before we move on in the course, because we're going to see this topic come up, or this concept come up over and over and over again, and that involves graphing a two-dimensional graph or a two-dimensional line, even though there's multiple independent variables. Okay, so if we think back to our original consumption function in this chapter, we found that consumption was equal to 75 plus 0.75 times our level of income. What we're going to do here is we're going to add an additional independent variable. We're going to add the interest rate to our consumption function, because the interest rate is really the return on savings for an individual. So as that interest rate goes up, we're going to see a reduction in consumption, and that's what our consumption function here is showing us. So we have this minus 25 times the interest rate, all right, at the end of our consumption function. Now, before I get into graphing this kind of multiple times and showing you how to deal with multiple independent variables, all right, I want to point out that I'm going to call consumption, I'm going to denote that as C, so capital C, that's going to be equal to 75 plus 0.75 times Y. So income is going to be Y really throughout this book and throughout your economic lives. I'm going to call the interest rate R. That's nothing that's too crazy there. So just keep an eye out for that income. The more that you do problems like this, the more comfortable you're going to get with income being written as Y. Okay, so how do we deal with the fact that we've got multiple independent variables? Well, what we're going to do is we're going to hold one of them constant, and in particular, we're going to hold the interest rate constant. Really, we'll start simple. We'll start with 0. All right, so let's imagine that interest rate is 0. We can ask ourselves, well, what's the consumption function going to be? Well, we're going to have consumption equal to 75 plus 0.75 times Y minus 25 times 0. Okay, so that was I did a little more work than I needed to there, because this minus 25 times 0 is just going to go away, and we're going to be left with our original consumption function. So 75 plus 0.75 times Y. Okay, so let's go ahead and graph this over here on our consumption and income graph. All right, we've got 75 as our intercept. We've got our line here, our consumption line. Go ahead and put that right there. And go ahead and just note that we've got 75 as our intercept. Consumption then is equal to 75 plus 0.75 times Y. And let's also note that this is happening when our interest rate is equal to 0, so we can go ahead and put that down. Okay, so we've held the interest rate constant at 0, but what happens to our consumption when this interest rate goes up? In particular, what happens to this consumption function? All right, so let's make R go up to 1. All right, and now let's plug in 1 into this consumption function. We've got 75 plus 0.75 times Y. All right, we're comfortable with this graph. We know what this looks like. But now let's subtract 25 times 1. Okay, so we got an interest rate of 1. Plug that into this consumption function. We're going to multiply that by negative 25. So now our consumption function becomes 75 plus 0.75 times Y minus 25. Okay, doing some detailed steps here, but this gives us 50 plus 0.75 times Y. Okay, so now we've got a new consumption function when this interest rate is equal to 1. So let's go ahead and put this on our graph here. We've got a similar or the same sloped consumption function as before, but now that intercept is a little bit lower, right? In particular, it's going to be at $50. Okay, so now our consumption function is equal to 75 plus 0.75 times Y minus 25 times 1. You might be sitting there saying, that seems like a lot to write. Yeah, that is a lot to write. So let's get rid of that, and let's say that our intercept is actually just 50, and let's call R equal to 1. Okay? So notice again that these two lines should be parallel. They should have the same slope. An increase in income is going to increase our consumption by 75. A dollar increase in income increases our consumption by 75 cents. But going from an interest rate of R equals 0 to R equals 1 is going to reduce that consumption by $25 at every level of income. Okay, let's do this one more time, and let's do it for interest rate equal to 2. So if our interest rate's equal to 2, again, we can hold that constant and just plug it into our equation. So we've got 75 plus 0.75 times y minus 25 times 2. Okay, so that means that our new consumption function will be 75 plus 0.75 times y, that original one, but now we're going to subtract $50 from this. So that interest rate has went up one more time. All right, so we're going to decrease that consumption by $50 now instead of 25. So now we have consumption equal to 75 minus 50. That's going to be 25 plus 0.75 times y. Okay, so now you should be looking at this saying, okay, I can see what's going on. We're increasing this interest rate from 0 to 1, 1 to 2. We're just plugging it right into the consumption function. So it doesn't really matter in this first case when r equals 0, it just drops out of the equation, the consumption function. When r is equal to 1, we have this minus 25 times 1, so we're going to reduce our consumption function by $25. When r is equal to 2, same process, we plug it into this consumption function, except now we've got minus 25 times 2, so we're going to reduce that consumption function by $50, and our new consumption function, all right, is going to be a little bit lower than our previous one. So go ahead and graph that out. We've got the same slope as before. All right, but now we've got an intercept of 25. So now our consumption function is equal to 25 plus 0.75 times y, and this is going to happen when r is equal to 2. All right, so there's a distance here between the red line and the blue line. That's just r1, r equaling 1%, or the interest rate equaling 1%, going to r equals 2%. Okay, so again, this is just a bunch of linear curves on a two-dimensional graph, but we're getting a lot of information out of these consumption functions. So if you're feeling good about this, I think we're ready to roll on the math for the entire course. If not, make sure you go back, change the consumption function, change the interest rates, make sure you feel comfortable with the graphs, what they're saying, and how different variables or different changes in your independent variables affect that dependent variable and how you're going to graph it. So hopefully that helps. Good luck, and we'll see you guys in the next question.